Hey, it's Max. Just a quick note before the episode. We recorded this before we had launched the open beta of Zed, but we have now done that. So if you want to try the editor, all you have to do is go over to Zed.dev and download it. Thanks.
All right, welcome back, everyone, to another episode of Sourcegraph Live. We're here with Max Brunsfeld today. Max is the creator of a lot of things. Is one of the core developers on Atom, the editor from GitHub, the first, web technologies based editor that was the pioneer of technologies like Electron that are now ubiquitous. He's also the creator of TreeSitter, the parser generator library that now also seems just as ubiquitous, if not, completely visible to end users. Basically, if you're using any sort of editor with modern syntax highlighting support, you're using TreeSitter. And lately, Max has been working on a bold new editor called Zed that is lightning fast and promises, I think, a lot of interesting collaboration features. So really excited to have you on the show today, Max. Thanks for joining.
Yeah, thanks so much for having me, Bian.
Cool. So I guess like the main attraction today is going to be Zed. So I want to maybe start there. And for starters, can you kind of say a little bit about Zed, what your motivations were behind starting a project like this, and what are kind of the main interesting features of it?
Yeah, so like you said, I spent a long time working on the Atom code editor, and one major problem that we faced on Atom was trying to make Atom fast, kind of by retrofitting after the fact, kind of after we had initially architected Atom with this other goal, which was making it possible to extend your code editor using JavaScript and CSS. That was like the primary mission of Atom, and then we had to try to make it fast after the fact. And we realized through that experience of all being on that team, my two co-founders, Nathan and Antonio, and I, that we sort of, although we loved like the working on Atom and the mission of Atom of making this a hackable code editor, that what we really the editor that we personally dreamed of and what had always wanted was a little different than that. It was focused, like, kind of the number one thing was we wanted our editor to be lightning fast, so that it would sort of have this vibe of getting out of your way and letting you focus on code and just never having that feeling of frustration that your editor was slowing you down. And so that was sort of like at the top of our mind when we set out, after the Atom project kind of was sunsetted and we were working for a while at GitHub on other things.
Yeah.
We kind of eventually, when we set out together to build our new code editor of our dreams, sort of like the things at the top of our mind were the performance thing, as well as trying to create a better way to work together on code. We sort of, the three of us had kind of, in the course of working together at GitHub, like sort of across three different locations on Earth, me on the West Coast and Nathan in Boulder, and then Antonio in Italy, so in very different time zones, developed these kind of different patterns of working together on code where we that were kind of not completely supported by the tools that we were using. We were at GitHub using GitHub all the time,
Yep.
communicating with each other with by default using pull requests and a lot of async writing. But Nathan and I in particular had sort of come up as programmers in companies that did a lot of pair programming and other kind of, we're in person and where you sat with other people and talked to them a lot, and code was a much less siloed experience. So everything was shared.
Yep.
And we really loved that. And that was a really great way for the three of us to work together when we were working on Atom, even though the tools didn't help us with that. And so for a while, we had a lot of iterations of our workflow over the years. We were using Screen Hero while that used to still be a thing before.
Oh, that was awesome.
Yeah, that was pretty good for what you could like click on the other person's screen and stuff.
Yep. That was
and
amazing.
we did different screen sharing solutions, but we've kind of, it's for all of us, a passion of ours was to try to like make the process of coding together, in particular for remote teams, but really just like overall, like a new, make the process of writing code just more fun, more collaborative, by making a better tool for it. And so that's kind of where we're at with Zed is we, Zed was sort of designed from the ground up to support real-time collaboration. So all the features are kind of built with that in mind to be replicated over the internet. And so we use that every day when we're developing Zed. We're kind of, we do pull requests and stuff, but we don't. We do our code review and our collaboration in a lot more sort of frequent and fine-grained of a way where we're just pulling each other in throughout the day and saying, hey, can we talk about this hard, tricky bit real quick? And so we're kind of in our with this company, what we're trying to do is sort of through dog fooding our workflow and like kind of pursuing this vision of what we want for ourselves, trying to create a better way to work together on code and kind of encode that in our tool in the editor.
That's awesome. So basically what I'm hearing is like you got the Atom dream team, people who've lived and breathed developer tools and have been at the forefront of pushing forward developer experience. You basically taken all the lessons that you've learned over many years of working on this stuff. And now you've come up with an editor that one is probably, I think it's like the fastest editor, hands down, out there. So like optimized for performance is a first-class feature that addresses a lot of the criticisms of Atom and more generally like Electron-based editors, including VS Code and I guess like many others now. And you've optimized for this kind of like new way, maybe not so much a new way, but just like a different way of collaborating. And I really like that because I think the industry we're in, it's very like trends based. And I think it's very like trendy right now to say, oh, developers like being async, especially in, this world of, all remote and whatnot. But the pendulum always swings too far. And I certainly think that there's a ton of value in just like chatting with someone live as we are now, doing that knowledge exchange, especially if you're able to see, where that other person's cursor is, what they're looking at. Talk through the code that way. And as far as I know, there aren't too many good solutions on that for the market. There's things like VS Code Live Share and things like that, but they're all like I've used a lot of them or tried to use them. They're all just like kind of janky, and it feels like maybe like an afterthought. Shipped that feature but didn't perhaps like follow all the way through. And so yeah, I'm excited to see what Zed brings to the table in that dimension as well.
Yeah, exactly.
Awesome. So I guess like without much further ado, should we just like show off a bit of the editor?
Yeah, I would love to. I'll share my screen and
Cool.
show you what Zed looks like today. So let's see, is my screen sharing? Sorry, I haven't used this. Great. Okay, so here's Zed. I'm looking at the tree sitter code base right now, and just to start off with, it's pretty familiar. It's a code editor. It's got tabs. It's got a terminal at the bottom. It's got a I don't know what that is. It's got a project browser on the left. It's got some familiar stuff. You can see kind of as I'm mousing around. It's running a language server and doing a lot of the normal language server stuff. It's giving me hover information about symbols, and I can jump to def to start getting into some of the unique things. I mean, the very first thing, the most unique thing right now is if you look here in the top right, I've got this contacts button. I can call people, and so I'll call Bian and just invite him into my copy of Tree Sitter, and now he's in here, and so I can see his cursor. And if I click on Bian's avatar now, I'm following him. So if he's kind of scrolls up and down or navigates the different files, I don't know if you want to kind of jump to def or something, command click on something. But yeah, I'm following you.
That's awesome.
And one thing I really like to do is I haven't showed you this, Bian, is like I'll kind of do a split and I'll kind of keep tabs on what Bian's doing in one side, and then in the other side I'll sort of be doing my own thing. So like on the Zed team, we'll often be like, oh, we should change the way this function works. Oh, you go update all the call sites and I'll change the definition, in such and such a way. And I can kind of see what the other person's doing in my project, where they're busily like fixing a bunch of compile errors, and I'll be doing my own thing on the left. And so, and then like we can converge and diverge. It's very fluid. And what's cool about it is it's not just trying to approach what you can do sitting next to someone in person, but in a remote setting, it's actually more powerful than that. You can't do stuff like this, where we're simultaneously looking at different parts of my code base in any other way besides like a dedicated editor for collaboration like this.
Yeah, I almost think that like we've been trained to think as developers like, oh, like the unit of development is actually like the smallest unit of development is a commit or something, and we got to push something up, and like the only way we can collaborate is either we're literally sitting side by side, or I push something up and you take a look at it later, and over the interface of Git. But I feel like in instances I can think of, like it's just so much faster and quicker to have someone that you're just like collaborating with, and you're both allowed to drive, and you're both allowed to kind of like explore the code base and make additions and changes simultaneously.
Yeah, I really think it frees up, like there's this certain type of conversation that's really great for code review where it's like I know what I need to do.
Yeah,
I can pretty much get it right. There's some, someone might suggest some changes, but I can go do it all and then ask for help. But when I need help before I can even start on something, I don't tend to reach for pull requests or any existing tool very much for that, because pull requests, the only thing you can put a comment on is a hunk in a diff that already exists somewhere. But if I'm just asking a question about a piece of code, a lot of times it's just so much easier to pull someone in right at the time and have them look at it with me.
Yeah, totally. Do you think that code review as like a part in your process is where you see a lot of folks using this, or are you kind of saying that like code review as a concept maybe shouldn't exist at all? Like, if you wrote your code collaboratively with someone else, then they're kind of already up to speed, and the review process is essentially just like submit this up to like CI/CD, get it to pass, and then you can like merge the thing that you together have worked with into the main trunk of the code base.
I really think there's room for both, and I imagine the collaboration experience on code as being more of this continuum where, I'm often like by default working by myself when I come in the morning, and then when I have a question, if it were for you, you might be online right now, and if you were, I probably would just want to talk to you synchronously, like. And today we would often do that in Slack or something where we'd sort of start our conversation that way.
Yep.
And then it might be the case that you're not online at this moment. And so there's this whole part of the workflow that we haven't tackled yet with Zed, but that we're sort of is kind of our next frontier right now. Up until now, we've been very focused on the most synchronous parts of the collaboration model. But what I imagine doing in the future is sort of blending these things where there'll also be a textual conversation discussion interface in Zed where I can, say if I have a question about this piece of code that I'm selecting on my screen, that I could just, if you weren't online, I could just type a question to you like I would in Slack, except that what's better about doing it here is that when you do come online, you can see my question and kind of jump to that moment in my project in the state it was in when I typed the question, and then if we overlap in time, so we're online together, we could just fluidly like start collaborating like this, like we are now together. But they're like, I sort of envision there being these different time scales of collaboration where sometimes it's more appropriate to use text and just lower friction.
Yep.
And then I could sort of create a code review with that same interface, but it would be sort of kind of like what code reviews are now, but like plus more, because the reviewer could jump into that full buffer very easily in their editor in the state that it was in when I made the comments and
Yeah.
sort of reply in there. And so it wouldn't be this hop back and forth from the editor to the web browser,
Yeah.
but it would just kind of all be fluid. That's our vision.
Does this kind of break the assumptions that we have about version control, maybe? Because if I'm jumping to the editor state that you were in when you had this question, is like Zed kind of like snapshotting things for me in the background so that later on, like my friend or my coworker can go in and like instantly jump to that point without me having to think about it, you know, explicitly call git commit.
We do imagine the Zed snapshotting things for you. I still think that version control will be a part of it too. I think like part of what will snapshot is what branch you were on, and there'll be some kind of awareness between the two. And version control is still going to be important, but I do think, you know, and I do think often it makes sense to have code reviews tied to branches still.
Yeah.
I just would love for the discussion to be, instead of like it all hanging off of the version control, I still think the version control is important, but I would love for the discussion to hang more off of the code authoring environment instead, because I just think it's a more powerful place to deal with the code. You can just do more
Yeah.
when you're in the code editor. And so I would love to sort of, I guess reduce how tightly coupled things are to your version control and Git in particular. And I imagine personally still using Git, and that being like, I still like Git, and I want to keep it in my workflow for the, you know, the near, for like, you know, medium term.
Yep. Yep.
But I just imagine it being like less sort of the home of all collaboration and more like a tool that we use for like persisting a history of our code, you know, but more like not the center of everything.
Yeah.
Is kind of the way I think about it.
Makes total sense. You know, one thing I've noticed in playing around with Zed myself is just how snappy the interface is. And it's like snappy in a way that maybe a little bit hard to convey on video, but like certain things just like typing latency. Like I don't know how to describe it, but it's just like so buttery smooth. Where like if I switch back to VS Code, like you probably wouldn't be able to detect it if just like watching a video, but like something about it, just like you're like those extra milliseconds for whatever reason make a difference to your perception, especially if like to type fast, which I think is a lot of developers.
Yeah, I obviously totally agree with that. I think it's really the subtle like difference in latency really affects how you feel when typing your code. And it's like before we made Zed, I think that the code editor that I most admired in that regard was Sublime Text. I think that's like a really like beautifully designed and fast editor. And in its day, I really think it was like the best experience in terms of like consistently fast performance. And you know, we on our website, like kind of what we shoot to do is, you know, match that or even exceed the performance of that. And we have these like performance metrics that we sort of put on there to brag basically, and like that we measured using the high-speed camera on an iPhone, so you can kind of get the end-to-end keyboard to monitor update, and we're like, you know, right, we're just edging out Sublime barely, which was a tough thing because Sublime is really, really excellent in that regard. But we're that's what we're shooting for, is like, you know, the best possible responsiveness.
Yeah. We have a question in the chat saying it sounds like a bit like a shareable version of the VS Code timeline. I don't actually know what VS Code timeline is. Do you know what that is?
No, I'm real familiar with LiveShare, but I don't know what the timeline is actually. But I think I think that question, I don't know. I'll have to look at it after, to be honest. Yeah.
Cool. Can you talk a little bit about the performance side of this? So, you know, you worked a lot on Atom. I'm sure you're fairly familiar with how Electron works. What are some of the things that Zed does differently that enables it to have such low latency and small memory footprint?
I think like the two main things that I would say is One, I mean, or actually three, like the very first thing is pretty obvious, but we wrote the whole thing in Rust, and we're just operating at a much lower level than we were than we were with Atom. Where with Atom, we're using Electron, obviously, and
Yeah.
so kind of we're dependent on the Chrome rendering engine to render the editor. Whereas with Zed, what we did was built our own UI framework in Rust that's kind of designed around using the GPU for all rendering. And so basically, like everything you see here, the app is sort of it's a Mac app where it's basically one big metal graphics drawing surface, and
Yep.
we sort of render the whole screen on every frame, kind of like a video game does, but just very efficiently using some custom graphics. Like basically like there's sort of a few primitive shapes that make up the UI of the editor. Like rectangles with rounded corners, drop shadows,
Yep.
text glyphs, images and SVGs, and like occasionally in some cases like these selections, they're kind of arbitrary Bezier paths.
Hmm.
But all that so it's like a pretty small number of like core things that we have graphic shaders to draw those things, and we um, kind of just optimize like the code path that like goes from our view state to the pixels on screen very by just using very low level graphics primitives to do it. And so it kind of like bought us a whole lot of time compared to how much time it took in Atom just to go from our view state to actually having graphics on screen. So that's like one big thing is that the graphics side of it. And then another is just using some of the techniques that Rust makes really straightforward to leverage for like
Can you zoom in?
off.
Sorry, real quick.
Yeah, maybe I'll take away this split. Yeah. Um, so yeah, I was going to say was like, in fact, maybe like while I'm talking about this, I should open up the Zed code base.
Cool.
Let me open that up too, so I can gesture at some Zed code. But like, kind of everything in Zed, all the computations are designed to be able to offload things to background threads in a really straightforward way, which like was just much more difficult in Atom because it sort of was a single-threaded app in the beginning.
Yep.
Largely driven by the way using Node.js and JavaScript, where it's like the multi-threading isn't supported very well in the language itself, and
Yep.
so like we had to sort of add it on after the fact using a combination of web workers and also like kind of particular algorithms we'd drop down to C++ and use threading. Whereas in Zed, like we're sort of set up to do everything on background threads out of the box. And so we kind of have this like pervasive approach of making all our data structures kind of use persistent data structures that are cheaply clonable. So you can kind of have this general data flow of, when you need to do something expensive, like reparse a buffer. Reparsing a buffer is often very fast because we use TreeSitter, which supports incremental parsing. But
Yep.
it's still like there's things you can do, like if I like put a quote, and so like a lot of the buffer changes syntax at once, or things like that, where
Yep.
we can't put a super strict bound on how long that's going to take. Then we structure that computation in a way where sort of the input state of the parsing is like something that can be cheaply clonable. Like we represent our text in a way that's like a persistent data structure, so we can clone it, then move to a background thread, parse it on a background thread, and bring it back to the main thread. And kind of in very many places in the Zed code base, we sort of have these like cheaply clonable, snapshotable data structures where like anything that we can't like look at and say with like certainty is going to take like a fixed amount of time, we do on a background thread, and which just keeps the main thread responsive.
That's awesome. We got a question in the chat. Why would I want to switch as a NeoVim user?
As a NeoVim user, I mean, I love Vim. I use Vim for a really long time. And Vim is, I don't even know of all the massive changes that have gone on to NeoVim since I was a Vim user. But what I really like about Zed, I mean, is compared to my experience using Vim is like, this is sort of not one of the core values I stated at the beginning, but it's like a secondary core value is like, it just works out of the box. Like if you want to, I don't know, edit some Rust and have good syntax highlighting and a language server.
Go to definition, find references provided by, so there's like built-in LSP support is my understanding.
There is, yeah. And so, it'll sort of be extensible in the future. Extensibility is something we kind of care a lot about coming from Atom, but is not our focus like for this early development period. But like right now, it's like we ship with support for Rust, and so you get you open up a Rust code base, you have the internal parsing as well as the language server just kind of works, and you don't have to do anything. And same thing with all the languages that we support. We really don't want the experience. I mean, people love customizing Vim. I used to love it like at one time when I was like younger and had more time to do computer stuff when I wasn't working. But it's just, like as much as I love Vim, I would say that it's like a kind of a second job and like getting it to like work, and like that has a lot of pluses, but the extensibility is really powerful. But where I'm at personally now in life, I don't really want to have that other job. I just want to like a tool that is kind of a little more modern and just works with modern development approaches out of the box. And so that's a difference. That's something we care a lot about with Zed. And then also it's just as fast and as Vim is, it's sort of evolved from a single threaded program. And like, I think there is a little bit of async support like in different ways in NeoVim. I know they've done a lot around that, but I still think like just starting today and building on like the most modern technology available, like we were able to do with Zed, we're just able to do things that I think are there's performance stuff that's just easier for us to do than I think is than for NeoVim.
One thing I would love to dive into is the kind of like built-in support for tree sitter and LSP. So like tree sitter is really interesting. For those who don't know, it's basically like a modern parser generator library. I guess like similar ish to things like Yak and Antler that came before it, but implemented in using much more modern technologies, and it's much more ergonomic and easy to dive into as a developer. And so I'd love to dive into how like tree sitter works, because like this is one of the magic pieces behind the editor. It basically allows you to provide language specific support in a language agnostic way, meaning like how do you get fast syntax highlighting over all the different languages in the world? You use this thing called tree sitter that actually somehow is aware of the syntax of all the different languages in the world. So can we dive into that a bit?
Yeah, like maybe before we go into tree sitter, I'll just sort of kind of list like how we use it in Zed. Like you said, we use tree sitter for syntax highlighting and things like this outline view where you're kind of seeing a tree of all the symbols in the file and you can fuzzy search them. These breadcrumbs that show at the top of the file. Some of these things are things that the language server protocol can do, but we kind of concluded we could make a better user experience by doing it ourselves using tree sitter, like better in the sense of we have a little more control over how these UI work when we kind of implement them ourselves. So there's that, and the auto indent uses tree sitter as well. Like something I'm proud of in Zed is like.
Can you zoom a little bit more?
Oh yeah, let me crank my font way up.
Thanks.
like certain like more complex auto indent use cases where if I type like self dot language registry dot foo, like are kind of, we're able to like decide on the indent like a little more precisely than you would be able to do, like kind of text editors before, that are a little more primitive and use like regexes for doing indentation. So anyway, like that's kind of, we use LSP for like really semantic stuff like jump to definition and find all refs. But yeah, tree sitter is kind of gives us this core ability to understand the syntax. So like, yeah, maybe we'll jump over to the tree sitter window here and you can kind of direct me how to
Yeah, do you mind if
give a
I
tour here.
screen sharing for a bit?
Absolutely, yeah.
I did some, so we had a preliminary chat yesterday, and so I did some kind of preliminary digging into the tree sitter code base. And so can you share my screen? And let me know if this is zoomed in enough. Okay. One saying it's not zoomed in enough. So, okay. So basically, this is kind of like an overview of the tree sitter code base. And I was specifically interested in how it generates.
Sorry, you're not sharing the screen. I'm not seeing
Oh
anything.
yeah, I'm not seeing it yet.
Oh. Okay. Oh, unable to share systems permissions.
Maybe while you're doing that, I'll answer this one question that came up in the chat from Bjorn. Is it? I recognize you from NeoVim about GPU support, like, which is, do we support GPU systems other than the Apple Metal library? And yeah, the plan is to be cross-platform in the future. We kind of focusing on Mac OS for now, just because we're a small team, but we definitely want to support Windows and Linux before we release Zed 1.0. As well as web. We want to get Zed running in a web browser as well. Anyway, go ahead. See if I can find any other questions while Beyond is setting up screen sharing.
Sorry, folks. We should have run through this earlier. Max, do you want to talk about a little bit more about kind of like the backstory of how you formed the team?
Yeah. So let's see. So like the very long backstory is that my co-founder Nathan and I met before I even really learned to program, and he kind of had a lot to do with how I originally got into programming. Was through working with him on a side project of his that was a coding project, and we kind of like, yeah, I don't know. To make a long story short, we like, I got my first programming job after like spending a summer hacking with him on a side project, and we stayed in touch, on and off until he went and joined the Atom team, and I eventually joined GitHub too to work on that. This was kind of after I had been like hacking on Tree Sitter for a couple of years, but it was still sort of a work in progress. And pretty soon after I joined the Atom team, our other co-founder Antonio kind of met us through open source, through opening pull requests on Atom, and yeah, the three of us started just kind of working together really closely, focusing a lot on the like fixing Atom's performance together, and kind of bonded over this shared struggle of trying to make Atom fast. I see you got the screen share up. Maybe
Cool. Yeah, I got the screen share up. That's an awesome backstory. Did you know that you wanted to make it kind of like a collaborative editing experience from the get-go, or did that kind of emerge over time?
that was something we put a lot of work into on Atom. That Atom had this sort of package that we built called Teletype that was like our early explorations. Mostly Nathan and Antonio did a kind of deep dive into the CRDT literature to sort of figure out. That was kind of their first crack at figuring out collaborative real-time editing.
Yep.
And so we knew with it was something we always wanted to pursue, is like making coding more social in that way. But in Atom, it just didn't. We kind of weren't starting from the right place to really do it. So that was always part of our, like, if we got to build our own code editor, it was going to be fast and it was going to be social.
Yeah, that's awesome. CRDT, and I think like the older tech is called operational transforms. We looked at
That's right.
that a couple years back when we kind of like Sourcegraph. This is a fun piece of trivia. We actually prototyped a kind of collaborative editor many years back, very briefly. But those algorithms are very difficult to get right. There's a lot of bugs and issues that can go wrong. It requires just reasoning about a lot of shared states. So kudos to you all for making it just work, and in a way that's just like really smooth.
Thank you.
Question in the chat: did any of X-Ray, or at least the experience of it, make it into Zed? First of all, what's X-Ray?
So X-Ray was like a project after Atom got sunsetted, after Microsoft bought GitHub. A part of the Atom team kind of got put onto this project that was about other applications of collaborative editing within GitHub, and it was sort of this experimental project called X-Ray, and it was like a Rust rewrite of Atom. It was a little different. It was different than Zed in that it was like still trying to use the web as like the ultimate front end, a layer of rendering, but it was like a Rust library was all the internal logic of the editor. And yeah, at the time, trying to find that question. Like at the time we were also learning a lot from this other Rust code editor project called Zai that was kind of being led by this guy Rafe Levine, there was a lot of learnings there from like that first go around that I wasn't as involved in, but Nathan and Antonio kind of had. That was like, while still at GitHub, had this sort of first attempt at doing CRDTs and like building a code editor in Rust that
cool
before Zed.
Awesome. All right, I'm gonna share my screen. See if we can get it back up. Okay, so I want to dive into Tree Sitter because that's one of the cool, I think, pieces or building blocks that Zed uses to enable syntax highlighting and just kind of a general awareness of programming language structure. And I think it's like, today, OpenAI announced GPT-4, and everyone's excited about language models and AI and dev tools. But I think like oftentimes we forget that, hey, we've had this technology. It's called a parser that can tell you all the like pieces of information, all the structure in a code base that you'd want to know, and that's existed for a while. But the ability to generate a parser for a language, for each language in a way that doesn't require like writing a lot of code that's specific to that language, that's relatively non-trivial, and that's what Tree Sitter does, and it makes very accessible to modern developers. So it's kind of cool to dive into this library. So what I want to start with is, Tree Sitter, what is it? It's a parser generator. What that means is it executes parsers it generates and executes parsers for languages following a language specification. So basically the idea is you define the grammar of your language, you feed it to Tree Sitter, and Tree Sitter will spit out a program that will parse a blob of text into an abstract syntax tree, which is the structured representation of that language. And so, for example, this is an example grammar. So this is the grammar for tree sitter Rust. It's defined in a JavaScript file, but essentially the gist of it here is that there are these rules that define expansions, or I guess productions would be the technical term. And so the idea is that you start with a source file, and a source file is composed of a series of statements. And each statement can be expanded into a choice of either an expression or a declaration. An expression can be a sequence of, sub-expressions, or maybe sub-expressions ending with this block, and so on and so forth. And so, yeah, so walking through this.
Hey, sorry, for some reason my audio cut out, but I kind of heard the last part of what you were saying. So yeah, sorry, got disoriented there.
No worries.
I basically, when you started screen sharing, that my audio cut out and then just cut back in. So yeah, I don't know.
I was just giving an overview of like the grammar. So I was just showing off. Let's see. I guess I have to stop. I can only share tab by tab. So this is a grammar for the Rust language. And so basically, this is a definition of Rust. This is basically defining the structure of Rust. It's the structure of the source files. They're composed of statements. Statements expand to expressions and declarations. Declarations can be basically any of the declaration types. You got macros, you got functions, et cetera, et cetera. And the basic idea of tree sitter is that you define these grammar files, and then you can just pass these off to tree sitter, and it will generate a program that parses your language of choice into a syntax tree, which is pretty cool.
Yeah, exactly.
So yeah, I just wanted to walk through some of the code here because I think it's kind of interesting. So Max, talk to us about this like generate subcommand. This, as I understand it, is the command that takes in this kind of like grammar.js file and spits out a parser for the language defined in that grammar.
Yeah, that's right. You can kind of like think of tree sitter as being like composed of these two main parts that you sort of use at different times. Like one is about generating parsers, when you are adding support for a new language. So you're writing a grammar for that language. And so this is a command line subcommand that you would run that basically reads in that JS file that you were just showing. That's the grammar, and does a bunch of processing of that grammar to ultimately build this this C file that's like the parser for that language that's composed mainly of this state machine for doing the parsing.
Yeah.
And so
C file looks like.
And here's sort of the top of the C file. This kind of mainly what's in there is these big static arrays of different types of data. The main thing is what's called the parse table, which is
it is huge.
It's long, yeah. Like luckily it compiles to like some binary, which is nowhere near as big as the C source code. That's kind of what you ultimately use. But yeah, here's a part of the parse table, which is basically this big map that says, there's a certain number of states, and if you're in state blah and you see the next grammar symbol of, say, a curly brace, what do you do? And it's like operating on this stack where you're either pushing tokens onto your stack, or when you come to the end of a certain subtree, you pop nodes off of your stack and group them into a new parent node and push that onto the stack in their place. So it's building the syntax tree bottom up.
So as I understand, one of the innovations in tree sitter that distinguishes it from previous parser generators, because like there have been parser generators that people use in the past. I think when I was taking compilers in college, I think we used some variant of Yak / Antler. But one of the things that's cool about tree sitter is that normally if you use one of those other tools, it would spit out a program like this. It would be inscrutable, and that would just be your parser. As I understand it, tree sitter actually splits the logic across this C program to some code that's actually just like language agnostic. That's written in Rust. Is that right?
That's right. It's actually written in C, but there is a Rust binding to it. And
Okay,
then
got it.
the C is kind of what enables it to be used. So like in other code bases like NeoVim or Emacs and stuff. But
Okay.
so it's a small library that sort of implements the kind of language agnostic, like you said, parsing algorithm of this kind of parsing theory that we use. That's GLR, which is about basically building parse trees in a bottom up fashion in a way that it can tolerate certain forms of ambiguity. And also, like, you know, part of the reason why it's split up like this is that there's some other kind of non-trivial logic that's in that library for doing things like error recovery, where it'll tolerate kind of invalid syntax, and also incremental parsing, where it's like can reuse parts of the unchanged parts of an old tree when you make it change. So
Yeah.
that's all in this, like you said, in a core library that you would kind of use in your application if you wanted to use tree sitter, and that is kind of independent of any language. And then you use that library in conjunction with these generated parsers to actually parse stuff.
Now, where is that library defined in this code base? Like, what would I search for?
It's in a directory. I think is the top level directory is lib in tree sitter.
Okay.
And it's like there's C code in there. So there's like a file in there called parser.c that contains a lot of it. But yeah, so here you're you know,
Okay, got
this
it.
has got a lot of the actual parsing logic in there. And then there's another file, tree.c, that's like the syntax, or subtree.c, that has like the logic for like representing the syntax tree. Uh,
Okay, cool.
and yeah, and so there's just kind of a few objects that the library exports, like you have trees and parsers, and
Interesting.
those
Now,
are
now, why did you write this in C instead of Rust? Like, if it's agnostic to the language, why write it in C?
I probably would have written it in Rust if Rust were like mature at the time I was doing this. I love Rust, but like at the time I was sort of my thought was like I want this to be a lot. It's if it seemed like a kind of a gnarly algorithms that I was going to have to implement. And so I thought, oh, I don't know what language, like I don't want to implement it in like JavaScript because then I'd only be able to use it in apps that are written in JavaScript. And so same, Python, anything like that. I wanted it to be in a low level language so you could kind of create bindings to it
Yeah.
from different application languages. And so at the time, I was starting this in like, I don't know how long, probably 2013 or something.
Yeah.
It was that there was Rust, but Rust was like a really different than it is now, and it didn't seem to me like it was kind of like I don't know the right thing at the time.
Yeah, makes sense. So, where are the C bindings then? I've never actually seen like Rust to C bindings. Is that something that we could find in this library?
Yeah, so there's a generated Rust file that does a lot of it. That's called binding.rs, I think. That's in. Am I wrong? It's in the lib folder. Binding.
Binding Rust.
Bindings. Yeah, it's that bindings.rs. It's sort of like the fourth or fifth. So
Okay.
this one's generated, and it's kind of there's this Rust program called bindgen that'll read a C header file and generate like declarations of the Rust functions. The
Okay.
cool thing about Rust is like it can just all you got to do is like declare this function, the C function, as a Rust, give it a Rust signature, and then the Rust can like link to it directly, and you can call it with um, very little overhead.
Yeah.
This is like basically just the C header file for the library translated into Rust directly, and
Yep.
then
Yep.
like a high level like layer on top of this that I think is just called lib.rs. That's like in the same folder as this. Yeah, that one, that top one, I think. And this kind of has like Rust like structs and impls, so it's got a more like modern safe
I
interface.
see. Yeah. Hey Max, let me ask you this. Like, I'm looking through this code base, and like you basically like your name's all over this. So you didn't just create this library. You basically like wrote most of it. What is your secret for being so productive? like, you got any tips and tricks for the rest of us, like about your development process?
I don't know. I would say like this was a very specific period of my life. It was like before I had children, and I was like working. I had this job where I was doing like web development, like Rails and iOS development, kind of different, really different to this stuff. And I was like looking for this outlet of like I had never done like computer science stuff, so I kind of wanted like like a more like I don't know, kind of more like intense like logic thing to like work on as a hobby. And um, so for me, like the best way to learn a new topic was to kind of have a project that I was trying to build and just put, instead of like just going cover to cover through a topic, like
Yeah.
pulling as I needed it to build something. And so I just decided to, I think the one trick that I did was just to stay focused for a really long time on one thing. And like it was, for whatever reason, it was, I think it was just like I had this feeling of like, oh, what can I do to contribute to this cool like open source world that I'm now becoming? It was like back when I was
Yeah.
first programming, I was first seeing how cool like open source was like on GitHub, and I was like, well, what can my thing be that I could put out there? And so I just decided, this should exist. There should be incremental parsing.
Yeah.
It's very clear that it would be useful, and it doesn't. I didn't see like a good, like library. There was like paper. That was the other thing about it was there was academic papers about it, but there wasn't like a nice like library to do it. So I was just
Yeah.
like, that's a good. I can just stick with this for a really long time, and it was years of just hacking a little bit at a time.
What makes it all the more impressive is, if I recall correctly from when you had on the podcast for your backstory, like, you're not a compiler's person. Like, you didn't have like a background in compilers or programming languages. You kind of just learned all this stuff on the job, as it were, right?
Yeah, I did. I was like parsing. How do you do that? And pulled up a Wikipedia article on parsing, and I even like kind of didn't understand it all. Like I set out to build Tree Sitter and like didn't really understand how LR parsing worked, even the theory of it, and just started kind of implementing what I did understand and kind
Yeah.
of rediscovered for myself, like, oh, that's like I remember I implemented sort of a non-working version that seemed simpler and made more sense to me. And it ended up that what I first implemented was called LR0 parsing, where you don't in building the state machine, like there's less context that you carry around. So I kind of rediscovered, oh, that's why there's this thing LR1 where you have one token of look ahead that you carry, because like it makes like I saw what happened when you didn't do that, and like it didn't
Yep.
work. So it's just kind of, I don't know, it was very like stubbornly just only doing what I could like kind of made sense to me, and that was like kind of evolved as I implemented it.
Cool. That's awesome. All right, so we are almost at the end of the hour. If folks have any last questions they want to ask, pop them in the chat. I'll just ask you, Max. What are the things that people should do if they want to try out Zed in the near future?
Yeah, if you have a Mac, go to Zed.dev and you can get on our waitlist for our alpha. We're planning on opening up it to more people soon, but right now there's sort of a wait list that you need to get on to try the editor. And give us your feedback on. We have so Zed is not open source yet. We're kind of planning to open source it once we untangle the back-end pieces that we intend to keep closed source from the rest of it. Right now we're kind of moving fast and got it all together. But we do have an open source repo that's just for issues for people to give us feedback. And so we love it if folks could check out the editor, especially if you want to try out the collaboration experience and let us know what you think of it, and give us feedback. Can I also demo in the last minute one thing that I wanted to show in Zed, but I didn't?
Yes.
Let me share my screen super quick, if we have time. Like, the one other thing that I really like in Zed is like we're really kind of care a lot about keyboard control, and so we use this when you do thing like a find all refs in Zed. We open the results, or when you do a project search, if I do like a regex search in the editor, we open all those like multi-file data sets in this view called a multi-buffer, which you can edit multiple files at once using multiple cursors. And you can just use all the regular editor keyboard shortcuts to navigate around. And this is just something we sort of use it also when you're kind of looking at all your compile errors in your project. And so it's just kind of like a different take that we have that I had never seen in another code editor of showing these multi-file data sets that I think is really cool.
Yeah, that's super slick. It's kind of like the VS Code earthquake view, but on steroids almost, because you can have as many views as possible. In the last 2 minutes, we did have one question. Have you explored coroutine-based parsers at all?
I don't know anything about coroutine-based parsers. Yeah, I went with this table-driven LR parsing thing because there was already established theory about how to make it incremental in a code editor, and that was a really important thing for TreeSitter for me, was to make it efficient to reparse after an edit. And so as far as I know, there isn't the same level of like research that had gone into other parsing like kind of paradigms, except for these table driven ones. And that's why I went with LR parsing.
Cool. All right. Well, unfortunately, we are absolutely out of time, but I feel like there's enough here to warrant another live stream at some point. So we'll have to have you back on maybe when Zed is generally available, and perhaps open source. Maybe we can dive into some of the Zed internals and get kind of a source level understanding of how it's so fast. But thank you so much, Max, for joining us today. This was awesome. Thank you for sharing Zed, and looking forward to seeing more people try it out.
Thank you so much. Yeah, it's always fun to talk to you. All right.
Take care.
Bye.
See you, everyone.